Hello, my name is Xiaotong Liu. This is a pre-recorded presentation for the 2021 meeting of the Society for Mathematical Psychology. Today, I'm going to talk about testing sample-based accounts of probability judgments using a ranking task. Sample-based normative models of probability judgments assume that people inherently hold coherent sets of beliefs. These models assume people work on samples taken from underlying probability distributions in mind to generate explicit judgments. One limitation with testing these models is that they have mainly been investigated in the probability estimation task, which has several problems. For example, sampling parameters often cannot be estimated on the individual level without assuming the conditional distribution of estimation data. We propose a ranking task to test one existing sample-based model, the probability theory plus noise model, or PT+N model in short. We argue that the ranking task can overcome some of the limitations that the estimation task has. In the ranking task, participants will be asked to rank 4 events, A, not A, B, and not B. Following the complement rule, only 8 of the 24 linear rankings are logically possible. We further break down the illogical rankings into 2 categories. It may be the case that people provide an illogical ranking where both events A and not A are ranked above both B and not B, or it may be the case that in an illogical ranking, A and not A receive neither the highest 2 nor the lowest 2 ranks, but the relationships of A higher than B and not A higher than not B simultaneously hold. In an experiment, 49 participants were asked to rank 4 different event sets consisting of A, not A, B, and not B. On average, around 2 out of the 4 rankings that participants provided were logically impossible. An interesting question is then if it is an actual reasoning bias or the consequence of mental sampling. We answer the question by first deriving the predictions from the PT+N model for rankings. Based on the core assumptions in the original model, we derive an analytic equation for the probabilities of getting each of the possible 24 linear rankings. The PT+N model assumes that when making probability judgments, decision maker samples a total of n instances from the underlying probabilities. The number of critical instances indicating the event of interest from n instances can be modeled by a binomial distribution. PT+N model also assumes A can be mistaken for not A with a chance D or vice versa. Additionally, we assume that one uses the same sample size to create a ranking. For any event to be ranked higher than another event, it must receive a greater number of critical events. A simulation study was conducted to implement the analytical equation with different parameter values. Specifically, we vary the total sample size n from 1 to 10, set the error rate to be either 0 or 0.3, and manipulate the separation of underlying beliefs. In one condition, rankings are generated for only extreme events near the ends of the probability scale. In another condition, rankings are generated for only indifferent events near the middle of the probability scale. The PT+N model predicts that when ranking only extreme events, on average, it has a higher rate of providing logically possible rankings and a lower rate of providing type 1 illogical rankings. To summarize, we introduce a novel way to investigate probability judgments, and the ranking task offers a method to test the PT+N model. Specific qualitative patterns should appear in empirical data according to this model. Moreover, since we know the distribution of rankings conditional on sampling parameters, the PT+N model can also be fitted on the individual level. This is also a future step we want to take.